Hello Legacy students, Marsh here. So today we're going to look at rectangles, rhombuses, and squares. Oh my. So you're going to want that foldable we made in class together that we've been putting all of our quadrilateral information in. You're going to want a calculator and then also some color pencils to draw in some stuff. So today we're going to look at three of your tabs. We're going to look at rectangles, rhombuses, and squares. The first one we're going to talk about is a rectangle. Now you've probably seen rectangles since the beginning of your time learning shapes, but let's talk about what is in fact a rectangle. All a rectangle is a parallelogram. So if you think of parallelogram like basically the grandfather of the quadrilaterals, a rectangle is a parallelogram, but he's just kind of special because he has just four right angles. So, some properties about a rectangle. First thing, opposite sides are parallel. So we still do have our opposite sides parallel, just like our parallelogram. He inherited that information from a parallelogram. So if I mark that in, I have opposite sides parallel. You also know opposite sides are congruent. So this side is congruent to that side. This side is congruent to that side. But notice, guys, they are not technically congruent to one another yet. You also know opposite angles are congruent. So you know this angle is congruent to that angle, and this angle is congruent to this angle as well. Consecutive angles are still supplementary. They still add up to 180. Diagonals, they bisect one another. This is still from parallelograms. So what that means is that this from right here to right here is the same as from right here to right here. Same thing, this piece right here is congruent to this piece right there. Now, here's some new properties that rectangles have that a parallelogram doesn't. They have four right angles, and you know that about a rectangle because you've seen them before. So this is a right angle, this is a right angle, this is a right angle, and this is a right angle as well. Also, diagonals are congruent to one another. So if I would label the picture here A, B, C, D, I would know that BD is congruent to AC. Alright, so let's take a look at some examples here. So example 1, quadrilateral RSTU is a rectangle with diagonals that intersect at P. So let's go ahead and draw that in here. So I got RSTU, and they have diagonals that intersect at a point called P. If the measure of angle RSU, so RSU, okay, this angle right here, if it is 3x minus 5 and UST, where is UST? UST, so right here is 4x plus 4. I need to find the value of x. Okay, what do we know about rectangles? If I look at my properties here, what do we know about angles in a rectangle? Well, we know opposite angles are congruent. That's not going to help me. Consecutive angles are supplementary. That's not going to help me. But I do know, guys, that this angle S right here, he is right 90 degrees. So I know that these two together have to make 90 degrees. So I know 3x minus 5 plus 4x plus 4 has to equal 90 degrees. So let's add together. I get 7x minus 1 equals 90. So it looks like I need to add 1 to get x alone. Divided by 7, it looks like. So x equals 91 divided by 7. Let me do that on my calculator really quick. 13. X is 13. Let's try number 2. So quadrilateral ABCD is a rectangle with diagonals that intersect at point P. So almost the same diagram I have to draw again. So we get A, B, C, D, and they intersect at a point P. Okay, AC, full length here, is 4x minus 13, and DP is x plus 7. Let's find the value of x. Ooh. What do I know about diagonals? I know diagonals bisect each other. and I know diagonals are congruent. Well, if they bisect each other, that would tell me, oh, dp, not pb. X plus 7. Well, actually, wouldn't pb also be x plus 7? Because these are bisected. So if dp has a measure of x plus 7, bp also has to. And I know AC is 4x minus 13. So I know db has to be x plus 7 plus x plus 7, right? That would have to be db. Well, we know based on our properties of rectangles that diagonals are congruent. So I know that AC has to be equal to db. And they told us AC is 4x minus 13. So I can set 4x minus 13 equal to this together. So that would be 2x plus 14, because that is dp plus pb. So let's solve for x. So it looks like we need to subtract 2x, add 13 to both sides. Doing some math quick. It's 2x equals 27. Divide by 2. I get x equals 13.5. What I'm going to have you do is example 3. Go ahead and complete example 3 on your own. We'll look at them when we get to class. I'll give you the answers of what you should have gotten, but go ahead and try that one on your own. Now let's talk about rhombuses. What is a rhombus? Well, all he is he's a parallelogram that has opposite sides parallel and equal, just like a normal parallelogram. He is special, however, because all sides have equal length. So we know all sides are congruent, ultimately. What some other stuff, we still know opposite sides are parallel, so this side is parallel to that side, this side is parallel to that side. Opposite sides are congruent. This side is congruent to that side. This side's congruent to that side. And I know opposite angles are congruent. So I still know that guy and that guy are congruent, and this guy and this guy are congruent. Consecutive angles are still supplementary, no difference there. Diagonals bisect each other, so just like in a parallelogram, this side was congruent to that side, so the little pieces in the middle, and then this piece was congruent to that piece. Here's the new stuff, though. We now know that we have 4 congruent sides, so that means actually that each side has the same measure. So instead of being this side is congruent with this side, we actually have all 4 sides congruent to one another. Diagonals are perpendicular, and if you remember back from that word, perpendicular meant 90 degrees. So what that means is in the middle here, we actually have a bunch of 90-degree angles for our triangles around the edges. And then also, diagonals bisect opposite angles. What does it mean to bisect? Well, what that means is that this little piece right here is congruent to this piece right here. They cut it perfectly in half. Same thing at each angle. This piece is congruent to that piece. And then this guy is congruent to that guy. And finally, this guy is congruent to that guy. Now notice how I didn't color them all the same. They're not all going to be the same. However, when they're bisecting each piece of that angle, the halves of the big angle are congruent to one another. So let's try a couple of examples here dealing with rhombi. So I have measure of angle RST, so the big guy is 67 degrees. Find RSW. This piece right here. Well, notice guys, I have a diagonal, and I know diagonals bisect angles. So if the full angle is 67, this has to be half. So what I can do is do 67 divided by 2 to find RSW, which would give me 33.5 degrees. for my R as W. That wasn't too bad, right? Example 2, measure of SVT if the measure of STV, so big, this guy, is 135 degrees. So they want us to find SVT, so this angle right here. This might take a bit. How can I do this? Well, I know that the big angle plus this big angle is supplementary because that is parallelogram, right? And we have a parallel sides. So I know that 135 plus this angle plus this little other angle is 180. Well, if I call SVT x, based on that I have a diagonal cutting this angle in half, RVT in half, I know that RVS also has to be x, right? Because this is cutting in half. If this is 35, this also has to be 35. So together, this angle has to make me 2x, right? X plus x, that's 2x. So I know that 2x plus 135 has to equal 180. Let's go ahead and solve. So let's subtract 135. And I get 45. Divide by 2. So I get x equals 22.5. Let's try another one. Measure of angle SWT, this guy right here, is 2x plus 8. Find x. Well, that's maddeningly unhelpful, but I do know that diagonals are perpendicular, right? We talked about that, how this is a 90-degree angle. So I know that 2x plus 8 has to equal 90. So let's go ahead and solve. Subtract 8. So I get 82. Divide by 2. X is 41. Okay, what I'm going to have you do, I'm going to have you do the fourth example on your own. Try that one. See if you can solve it. I will tell you the answer in class. And the final one we're going to talk about, a square. Basically, square is a rectangle and a rhombus put into one. So basically, it's the child of a rectangle and a rhombus. What a square is, 4 equal sides, 4 right angles. And you've known that probably since you were a kid. Still, same things hold up though. Opposite sides are in fact still parallel. So this side is parallel to this side, and this side is parallel to this side. Opposite sides are congruent, and actually every single one of them is congruent to one another. And then opposite angles are congruent. So this side is congruent to that side. This guy is congruent to that guy as well. Consecutive angles are still 180, still supplementary. Diagonals bisect each other yet. So this angle, that side to the middle is congruent to the middle to that side. Same thing going this way. We have 4 right angles now. So just like our rectangle, we have right angles in the corner. Diagonals are congruent, so that means this entire side is congruent to this entire side as well. 4 congruent sides, because it is in fact a square. Diagonals are perpendicular, just like inside of a rhombus, so this is all right angles inside there. And then diagonals bisect opposite angles, just like they did in a rhombus as well. Let's try a couple of examples inside of squares. So if I know the measure of angle AED is 5x plus 5, let's find x. So just like in the rhombus, diagonals bisect, or not diagonals bisect, perpendicular. So I know there is a 90-degree angle right here. So I know 5x plus 5 equals 90. Subtract my 5. I'll get it at 5x equals 85. Divide by 5. I get x equals 17. Let's try the next one. BAC, that's 5x. Find x. Well, that's not helpful. What do I know about angles? Look at my properties here. Diagonals bisect opposite angles, which would tell me, since this is 5x, this also has to be 5x, right? And I know this is a right angle. So I know it has to be 90 degrees. So I know that 5x plus 5x has to equal 90. AKA 10x equals 90, right? So x has to equal 9. That looks right. MH is 8. Find the measure of AH. So we need to find this right here, the diagonal. How can I find that information? Well, I know this guy has to be H, right? Because it is a square. Which would tell me, if I use Pythagorean theorem, I should be able to find this, right? Because this is a right angle. So 8 squared plus 8 squared equals whatever C is, C squared. So that would be 64 plus 64 equals C squared. Well, that is 128 equals C squared. Square root both sides. 64 times 2, so that would be 8 square root of 2 equals C. You know what? It's a 45, 45, 90 triangle. That kind of makes sense, because this is 45, because the full thing is 90 and it's split in half. So, I actually know that this is a 45, 45, 90 special right triangle. That's kind of neat that that shows back up inside of a square yet again. What I'm going to ask you guys to do is example number 4. Go ahead and complete that one before class tomorrow, and then we will make sure you got the right answer inside of class. And this is the end of this video. See you later, Sabers.